Hi everybody, today I'm going to show you on tutorial how to use PyRMD for virtual screening of activity compounds based on AA trained data. About PyRMD uses a random matrix discriminant to identify molecular features from activity compounds. With this, it's possible to screen a large data set to identify new active compounds easily and efficiently. So that's it. Let's get it started. Before to start to use the PRMD, we need to get two files. For benchmark mode, we need to file from ChEMBL or SMI file. And for screening, we needed this file and the database to screen. So now I teach you how you get these files. So the first file that we needed is a file for train the dataset to select the active and inactive compounds. It's a file from ChEMBL. So I will show you one target. For example, it's a target that uses it on paper. So I just search informations about this protein. I will select the specific target for us is from Homo sapiens, and the target mitogen activate protein. I will just scroll and in associate by activities, click here. I will get a lot of compounds for this target. So then I will download all the information in a CSV file that we use to upload and PRMD to train. So download this. No, that's okay. Now we got the file. This file have if this file has a lot of information, I will show you. So, but it's okay. We don't need to do anything here. Just look at this. It's a lot of information. That's okay. So I will extract this in this download the directory. Mm, And I will change the name to make easy to use the tool like M for MEK ChEMBL. Right. This is a file that you have that we use it for training our dataset. Okay, for using the screen mode, we need to get the second file, the important file to screen the new activity compounds. For this, we can go into MQ data website, and this website the website was used for get the file uh, for testing on the paper. We just click on download database. We directed another page. In this page, we have a lot of data with it has several compounds. For this, I will select one of these data, clicking download it for Smiles file, and after this, we download the file in Smile configuration. And now I will show you inside the file. We have the Smile format, Smile configuration, and some I think code from the Smile. And okay, you just this it's not necessary to change anything here on the file, and it's okay to use in PyRMD. I I would like to say for you that it's important that if you have a lot of uh, data, a lot of compounds on your database screen, uh, the PyRMD is working slowly. So for this, I select just 50,000 molecules to test and show how PyRMD works. So, okay, we have now the screen file and as well our the dataset to train and select the active and active compounds. It's okay for PyRMD works, and then let's go to use the PyRMD. So PyRMD is located on Google Colab and is easy to use. We have two cells. The first cell is to install the package. Just click here and wait some minutes. The packages have been installed. Now we need just do the configurations of PyRMD. As I said in the start of the video, we have a two mode, and you can. The first example is benchmark mode, and just select the benchmark, and we needed to upload our files in directory called upload. So just here upload and upload the database, okay, and upload the file to use to train the AI. So we have now two files, and for benchmark mode we skip uh, this step, and in here we put the name of the path from for results, and it's just okay. Is results directory, and you can create a name, a specific name. I will let this name. In the train data set is you use the ChEMBL database. That's this file here. So you need to click here and write the name of this file. At this case is M14 ChEMBL. Okay. Now, if you want to use another files with smile files for active that you select and specific, you can click in here, and put the smiles of active and inactive compounds. So in the finally, we can select the training parameters. Is this to probability of you find uh, true and false positives. And if you want to understand better, I suggest you to read the paper. I will let this number is okay to use as test. And if you write and check all configurations, you just click here and wait the results. Now we wait in the results for benchmark mode. So the benchmark has been finished, and in output we can see some results that explain the how was selected the active and inactive compounds, and the statistic scores used. It's not used, but uh, from the trained data set, and at final we got two pictures of the statistics parameters, and you can download this graphic in the left on Google Colab, here and here. And another result is clean train database, and MK results is from the score parameters. I will show this specific file, and clean train databases show to you. Let me select this too easy to see here in the parameters that active and inactive molecules have been selected. Okay, so just a good file. Now I will show you use the screen mode. So then you just click here, and the different, now you don't skip this step, you just put the name of the database that you will select to use it for search new active compounds. You just put the name of the file, that's this file here, and the screen output, the results, and the directed results. And now we click the SDF results as well, the compounding SDF file. So the train dataset is the same from the MK chamber. It's not the results of benchmark for just the start file from ChEMBL, and the epsilon cutoff, it's the same. Just if it's okay, you just click here and await the results again. So the screen mode, the running screen mode has been finished. In output, we got the results explained by PyRMD, and from about more or less 70,000 molecules, we got 2 compounds, 2 molecules, the candidates, an activity molecule from the target, the MEK14, and we have some files that is possible to can download it in SDF file for using a docking. And the next step, if you want to use it to understand the docking, you can search some videos on my channel using AutoDocBina and another planes and other tools, and you can download the SMILE configuration of these 2 compounds, and as well the database that show you informations about this candidate. Let me see let me show you example. Is the SMILE's configuration and similarity, the potential pain, so you can explore this information about your results. So the PyRMD is easy. It's easy to use it, and if you have any doubts about the PyRMD, you can write it on a comment in this video. I hope that it helped you in your project, and thank you very much to watch this video.